Yeah, my name is Derek, and I'm a PhD student at the University of Western Australia. And my topic is on implicit facial trustworthiness impressions. So first, have a look at these two faces and have a think to yourself, which face is more trustworthy? A lot of you probably gravitating towards face one. And it's quite an easy and quick decision to make, right? Well, research has shown that people tend to generally agree on which faces they find more or less trustworthy. And in this case, people do tend to choose face one. And as you just saw, even though we say don't judge a book by its cover, people tend to make all sorts of different judgments about others based on their faces alone. And trustworthiness is one of the primary dimensions of first impressions that we make based on other people's faces. Now, I've got one more question I want to ask you. Did you make the trustworthiness judgment because I asked you to? Or do you think you would have made the same judgment by yourself as soon as you saw the faces, even if I hadn't said anything? Well, this question is at the core of our study, because what we wanted to know was whether these trustworthiness impressions can be made implicitly or not. And what that means is whether people make these trust judgments without any explicit instruction to do so. And one of the reasons we wanted to do this was because in the trustworthiness literature, a lot of studies assume that trustworthiness impressions are made implicitly, yet a lot of the tasks often involve explicit instructions to judge the faces on trustworthiness. There's also been a bit of a debate in this field surrounding this question, and studies have found both evidence for and against implicit processing of trustworthiness. So the goal of our study was to help resolve this debate and determine whether trustworthiness impressions can be implicit or not. To do that, we used fast periodic visual stimulation, or FPVS, and more specifically the FPVS oddball paradigm. And in this paradigm, we present faces at a rate of 6 Hertz. So 6 faces per second is presented. Then every 6th face, we have an oddball face, which differs from the other faces in its trustworthiness. So for example, you could have, in a trial, you could have 5 untrustworthy faces, followed by 1 trustworthy face, or vice versa. And thus the trustworthiness of the faces are changing at a rate of 1 Hertz, or once per second. And here's an example of what a few trials would look like. And participants would see these trials back to back until the end of the task, and they would have their EEG recorded at the same time while they do this. So how does this paradigm work? Well, if participants are able to tell the difference or discriminate between trustworthy and untrustworthy faces, then we would expect to see a spike in their neural activity at the same rate at which the oddball faces appear. So that would be 1 Hertz in this case, and it looks something like this. And that's just signifying that whenever an oddball face shows up, the brain can tell the difference between that and all the other faces. And those of you who are familiar with EEG would also know that we would expect to find some responses at the harmonics as well. So something like this. And we would expect to see quite a large response at 6 Hertz as well, which would just be showing you the face detection of the faces that are being shown at 6 Hertz. So something like a steady state visual evoked potential. And this paradigm, the FPVS oddball paradigm, is perfect for looking at implicit processing, as no judgment of the faces are required. The participants just look at the screen and the faces are being presented while they do an orthogonal fixation cross task. So let's have a look at the results. What we're looking for is a significant amplitude at 1 Hertz and its harmonics. And that's exactly what we see here. And this suggests that trustworthiness was indeed processed implicitly. Whenever participants saw the oddball face, the brain responded to it. And as I saw before, we also see the large response at 6 Hertz as well. Additionally, we see that these responses are localized in the right occipital temporal region, which has previously been associated with face processing. So in conclusion, the take-home message is that we help resolve a debate in the field and show that trustworthiness impressions can be made implicitly. And this neural response that we measured to the oddballs using FPVS could be useful as a robust marker for trustworthiness impressions for future studies to use. Thank you everyone for listening, and I'd like to thank all my supervisors as well. And there's also a QR code to the journal article if you ever want to have a look. Thank you.